section 1-3 or 1.3, radicals and rational exponents, part 3 video. In this part video or part 3 video, we will take and learn how to write rational exponents, which means exponents that are fractions, in radical form and vice versa. So the first thing we've got to understand is if we have a variable raised to a power, it and its power is a fraction, then it corresponds to this as a radical. The denominator of that power is the root or index, okay? And then you have x to the a. So this is going to be the root or index, okay? And that's going to be the power of the variable. All right. So that's how this is written. Now, when you go to evaluate things, this form right here, x to the a, let me erase that. That's kind of bad. Is much easier to use to evaluate things such as numbers or whatnot. Okay, so just kind of be mindful. The black is how you transfer it back and forth, the red and the black. So if we look at this one, we have a negative power, and you know that if you have a negative power, that it needs to move. If it's in the numerator, it needs to go to the denominator, and then it will become positive. Now we have x to the 3 over 11, and we should see that that's 1 over. Well, that's the 11th root of x cubed. Okay, the 11th root of x cubed. 1 over the 11th root of x cubed. It's this negative moved it from the top to the denominator, so that's negative power rule, and then we just converted it based off of our conversion. Now, the radical expression, rewrite it in form. So we can take a radical and rewrite it back in form of a rational exponent. Okay, so the root is a 7, and the power there is a 6, so that's x to the 6 7th. So in this form, the a would be 6 and b would be 7, right? All right, let's look at another one. We're going to take 64, and we're going to put it in a radical form. Then we're also going to simplify it. Now, that means that this is 64. That is the cube root of 64, all right? And 64 is raised to the first power. So we can just leave it at 64, right? So we can make that go away. Now, what is the cube root of 64? You should know that it is 4. That means it's been simplified. Okay, so we took it from exponent form, wrote it as radical form, then we simplified it. Now, last one for section 1-3, radicals and rational exponents, is rationalizing not just a monomial, just one thing. We're going to do a binomial. And what we're going to use is called the conjugate. We're going to rationalize the conjugate. Now, the conjugate, we're going to multiply it. That is the conjugate. Okay. Now, how do you get the conjugate? Well, it's whatever this is with the sign changed on the second term. So what you're going to create is called a difference of squares. When you multiply this is going to be a difference of squares, meaning it won't have a linear term, which means the radical goes away. All right, we'll prove that. We'll show it. So we want to have this up top. 8 times 4 plus the square root of 11 over, I'm going to go ahead and split it since these are going to be multiplied. So that's 4 times 4 plus the square root of 11 minus the square root of 11 times 4 plus the square root of 11. So what I'm doing is just splitting my two binomials. You know, if you look at this, that's really that, and this is really that. It's FOIL, right? So we've got 32 plus 8 square root of 11 on the top, and this is 16, and this is plus 4 square root of 11. Remember, outside to outside, 4 times 1 is 4. I have no inside, so I've got a number and a radical, and we just bring them together. And then we'll do this, and that's minus 4 square root of 11. And then we have minus the square root of 121. All right, so these go to 0, okay? And then this becomes negative 11 because 121 happens to be a perfect square. So 16 minus 11 is nothing more than 5. Write that better. All right, so we have 32 plus 8 squared is 11 over 5. Now I have to check this to see if I can simplify this. That means I have to see if something will go into the 5, the 8, and the 32. And nothing does, so my final answer would be 32 plus 8 squared root is 11 all over 5. That's my final answer. And this concludes the last problem for section 1.3, radicals and rational exponents, part 3 video.